Okay. Hi everyone. This is Sachin Kumar from IIT Kanpur, doing a PhD in Advanced in Material Science and Engineering under the guidance of Kaustubh Kulkarni. And currently, I am working on the nickel-based superalloys, diffusion nickel-based superalloy. This is my first video lecture. I will start with introduction to the material science and engineering, and a series of videos will be coming soon on interesting facts and the concepts in material science and engineering. So let's start with the overview of today's lecture. That is, we will start only a few concepts we are covering in this chapter. That is history of material science and engineering. So what is material science and what is material engineering? So what is the difference between material science as well as a material engineering? There is a slight difference between these two. So we will know. So what is the importance of these two? What is the difference between these two? Okay. So, yeah. First of all, this is first of all we will get into the historical perspectives of the material science. So from the school days, we are knowing that the human beings are developed gradually with the growing the civilization. So we know that there are so many ages like Stone Age, Bronze Age, Iron Age, and the Steel Age. As a civilization, as a material is developed, or material science is developed, civilization is also developing. That means it's a directly proportional to the evolution of civilization. So initially, the human beings in a Stone Age, they are using cloth, skin, wood as their materials. But after that, they are using pure metals, sorry, pure metals and their alloys they are using. After that, they are using advanced materials such as composite material. So this is the development of civilization along with the materials. So in India, there is an improvement of a material also. So one of the best example is Delhi Iron Pillar, as all are aware of these things. So yes. So as we know that, so Delhi Iron Pillar is one of the best example that India is also a having best history of material science and engineering. It is established in 402 AD by Gupta dynasty in Bhopal, near Bhopal. So its height is about 7.4 meter in height. So Till now, it is not even a small rust is happened on the iron pillar. This is because of after a researcher, Indian scientist, after doing a research on the this iron pillar, it is the compositions of iron pillar is having a more quantity of phosphorus, that is 0.25% of phosphorus, and 0.15% of carbon and other alloying elements. Alloying elements which make the pillar covered with a corrosion resistance, a thin film, protective massive film which will prevent from the corrosion. Because of this, it's not at all corroded. This is a brief history. This is a brief history and of in olden days, in late 19th century. So after this, in late so after this, in late 19th century, so many researchers and scientists, they are correlating this structure and the properties of a material, properties of material to enhance their properties, is correlating and they're enhancing the properties of the materials. In late 19th century, that is Gibbs has correlated the atomic structure with the phase properties, various phases, with help of like thermodynamics. With thermodynamics of material, which helps to understand the behavior of a material, but how these materials are changed the phases and how they're with the changing the phases, how they are affecting with the performance and properties. This Gibbs has been started correlating the things, and he's known as a father of thermodynamics. In late 19th century, American scientist called as Gibbs demonstrated that the thermodynamics property related to the atomic structure in a various phases are related to the physical properties of a material. Introduced the thermodynamics of materials. let's begin with this introduction to after history. We'll get into the introduction of the to the material science and engineering. As in the previous slides, as I mentioned, there is a difference between material science as well as in a materials engineering. So material science involves investigating the that exists between the structure and the properties of a material. In contrast, whereas material engineering is on the basis of these structure and the properties correlations, structure and property correlation, correlation, or so designing the or engineering the structure of the material to produce a predetermined set of properties. This is called as material engineering. So this is the difference between these two. So let's talk about the components of this material engineering. So what are the main components? So how they are related? There are totally four main important components are there. First of all, processing, uh, structure, property, then it comes performance. So let's talk one by one. Structure. So structure is if a material is usually related to the arrangements of internal components. There may be a subatomic or atomic level arrangements. And the properties are inherent characteristics of a material. So for example, if you apply the load, a soft material is there and a hard material is there. Hard material will withstand the load for a load for longer duration of time. The same load is applied to the soft material, it will break. This is a soft and the hardness is a property of both materials. And performance. Performance is like, so what is the output? So the performance will be is affected by the properties. And whereas a structure is can be changed with the help of a processing. So what is the processing method? So how the processing method will be carried out, from which the structure can be varied. These are correlated with each other. So ultimately the processing, structure and properties will affect the performance of the materials. So if you want to get a desired properties via desired performance, so longer duration of time, lightweight materials in a aircraft, aerospace engineers, aerospace structures, we are using lightweight and high strength material. High strength. This is the performance of that materials. For example, so let's start with the after this difference between material science and material engineering. We will get into the different classification of materials. Totally, materials are characterized into four different classifications. That is, metals, ceramics, polymers, and composites. So, metals are the group of an composed of group of an materials which consisting of metal, non-metals, non-metallic elements such as carbon, nitrogens, metallic with a small quantity, relatively small quantity. The metal is a major quantity, whereas we can add non-metallic components such as uh, carbon, nitrogen, oxygen with a small quantity to to form an alloy. And let's come about ceramics. Ceramic are the compounds between the metallic and the non-metallic. They are almost frequently oxides, nitrides, and carbides. The most common example of ceramics are Al2O3, as you know that's Al2O3, that is aluminum oxide, silicon oxide, etc. So next comes under this is a polymers. It's a familiar with the plastics and the rubbers. It's a mainly consisting of organic compounds consisting of carbon, hydrogen, and other non-metallic elements such as oxygen, nitrogen, silicon. And composite materials are made up of combinations of these three: combination of metals, ceramics, and the polymers to obtain desired property. Desired property. To obtain the desired property, combination of these two will get into the composite materials. This is a nowadays this is a most researchers have been working and get and introducing a more new materials which is having the high strength and the low weight materials. Thank you. This is all about today. And if you have any doubts, please share in the comment box sections. Thank you.